Right, so today we've got a base station and we'll go through some of its parameters. He wants the power supply capacitors changing, if I remember from the letter. It's a Murphy CBH1500, which I've said before is a Spirits 40F transportable in a big box. So these were made for Great Universal mail order catalogue, and so it is a walkie-talkie in a big box. I don't want anyone to think these are splendid performance, because they're not. So just check power supply. He said he'd like it to do 4 watts. Well, I'm not sure that we've ever seen one do 4 watts, but I did say so. Yeah. Power supply. Right, so what we'll do, we'll plug this in. We have to change the mains plug on that. It's not of the shrouded type. So I'll worry about whether it's got the right fuse in when we change the mains plug. We'll do a pat test on this as well. But I don't expect there's going to be any safety issues, but it's just something we need to do at the same time. So we'll connect it up to the test equipment. It's a really good view, isn't it, of a dodgily painted case. Now then, we need to plug in an extension speaker. How do you do that then on this? So we can't get a cyanide reading, can we? No extension speaker socket. Right, we come with a standard Coffin Palmer branded mic, which is fine. They had a really little dinky one. These are wired a unique way. Switch on. Right, so we'll switch picture in picture on, and we'll make sure we're on the right camera. Does my camera move? I don't know. So transmit, we're in the 3 watt scale. It's doing more than 3 watts. It's actually doing, right now it's doing 3.8 watts. So I don't think they do more than this anyway, but that's fine. Mind you, when I've sorted the power supply, I think it might do less. I'm sure he said something about it doing 15 volts. So let's look at deviation. Wow, that's a bit low. 1.7 kilohertz, so that can be improved. Now look at what frequency it's doing. The test set's been on sufficiently long for me to be able to get a reading. It should be 27.79125. It's on the wrong channel, it's on channel 19. Try again. 27.79114. It's virtually spot on. So all we can do with the receive is listen to it. So I'm going to put 1 microvolt on the signal generator, and we'll dial in the appropriate frequency, 27.79125. So there we are. So let's put the RF gain to full, delta tune to central, turn down the squelch, noisy volume control. So that's 1 microvolt. We'll have to take the set apart to get a cyanide reading. So I would guess it's doing something about 0.9 microvolts. But we'll just make a note. I'm guessing 0.9 microvolts for 12 dB cyanide. That's Tango 21's ears. So we'll pause the video, take the lids off, and just get a proper reading. Well, have you ever seen anything like it? Is this some clever modification to stop it transmitting hum like they always do? So I don't know why. Oh, it's lost its grommet, hasn't it? We'll have to order a cable entry grommet. Oh. Yeah, it's got its earth connected, but not to the chassis of... Oh, not properly to the chassis of the transformer. That is awful. And these are the capacitors he was on about on the power supply, which is fair enough. And what does this screw do? It's just like a variable hum screw. It's a decking screw, isn't it? Somebody needs decking for doing that. Oh dear. Well, we'll just delay our little... Well, that's one screw anyway. And that's actually insulated from the bracket. That's half a mobile bracket, isn't it? Somebody's absolutely dying to have one of those brackets, and it's now been chopped in half. So the power supply, the transformer's going to go back where it came from. So the screw that's still there, I'll just put it in the front. Right. So, at least it was a fully shrouded transformer. Had I powered that up, and if it had been one with the normal tags on it, that would have been an interesting thing. So the idea was to get the cyanide reading off this, so we'll switch it back on. So we'll just connect the connector onto the back of the speaker. If I can just manage to hold it there. And I'll put the cyanide meter on the camera. There's 12. Let's see how wrong I was. 0.72 on that scale. 0.83 on the normal scale. So 0.83, I guess 0.9, so a little bit better than I thought, but it will do better than that. I didn't know they didn't have a heat sink on them. So one of his things was about the power supply doing too high a voltage. We'll just turn the volume down. I'll take the picture-in-picture off. change glasses. Oh, he said about no, the meter. There's only one meter lamp, and it's working. I'm sure that was one of his things in his letter. So how's this power supply work? It's 11.96. It's actually low. So I'm just wondering whether he measured it at this point. No, that was just the unregulated point. Anyway, it's 12.8, so it could do with coming up a fraction. Anyway, look, I'll dig the circuit diagram. We do have the circuits. In the meantime, I'll do these capacitors because... let's just make a note of that. I wish I could... This was two-way, and then I could say... we can't, if I did live stream, you know, I wouldn't be able to see any... You know, people can make comments. Well, I wouldn't be able to see them because it doesn't work like that, the internet here. 1196. 11.96 is too low. So we'll get those capacitors changed and we'll take it from there. Yeah, so I've put the first screw of that in because we're going to have to address that power lead. But when I look at the capacitors that have come out, in fact we'll just measure those, it's inadequate. I mean, this power supply, it's got to produce 2 amps, hasn't it? So, and if not 2 amps, 1.5. So this was some gunk coming out of that one. This is the main smoothing capacitor. It's only 1,000 microfarads. So what we're going to do is we're going to put 2,200 in instead. I don't do modifications, but this is so ludicrous. I mean, this is probably fine. It's just... No, it's a bit high, and that's usually indicative of imminent failure. I mean, all the other base stations, and they've got similar power supply arrangements, are all between 2,200 and 3,300 microfarads. 128 is a bit high. Don't think higher is better. It's usually meaning imminent failure. And I can see gunk from around the legs on this one. Let's just try this one. So let's look in contrast at 2 new 100 microfarads, which are Nikon ones. There you are, it's a bit tighter at 105. $97.9. And we're going to use one of these, which are not cheap. He's not going to love me for putting this in, but he is, because it's going to work better. Now, 2,114. Right, that's just to prove that the tester isn't rigged. Now we're probably going to have to do a hole difference here. So it's not that far different a footprint. So what I can do is we can put that leg in, and then we can scrape it just there, and I will drill an appropriate hole for that there, so it still mounts in the kind of the correct position. I shouldn't have to do this. It is a poor design, but at least we've got the square kit diagram. So I'll get on with this and we'll get back to you. Right, so that's put the 300 microfarad capacitors in and the 2200, which is a little bit fatter, but everything fits neatly without squashing anything. Right, so we'll power it up. And now we'll see what the voltage is, and then we'll adjust it accordingly. don't know what voltage this is supposed to be, so we may play safe at 13.2. Does it tell us? No. Got a core hanging right after the top there. So what was it? 22 volts for the input side. 20. So 11.96. We'll pop that up to 13.2 if we can. Certainly want it above 12.8. Pop that down a fraction. You can see how this is presets being screwdriver, but they were better off being too low than too high. I bet the transmitter needs turning down big time now. Let's go over to the picture-in-picture of that. So go back into transmit. 4.7 watts. Right, so we'll need to turn that down. So where's my old notes for this? So it's T11, T10, T98. 11, 10, 9. That's probably 8. Yes. So we still need to peak everything. That's peak. Nothing necessary. That's actually come up a bit. And now we need to drop. That one. Actually, we don't. We'll probably have to drop this one. I don't like that dangling out of the top. So we'll peak the back one. I'm going to check this with a spectrum analyzer. Now I could actually hear the power supply grumbling when it was tuned the other way around. So I think that's how it should be. So pop it on frequency while we're at it. We're so close. If it's adjustable. No, I can't see that it is straight away. Oh, it's done through an inductor, which is actually better. Transformer 14. Trouble is, that's 6. That's don't know. I'll be I'll just carefully touch that one because it's next to the crystal. Yes, that's affecting the frequency. Let's put the camera on that. We'll just have it there, spot on. I'll better take a photo of this and we'll do it like that. So 4 watt. I can actually hear it drawing less current from the transformer. Deviation, and without looking at the circuit, I'll guess it's that one. Testing. Wallow. Still wants a bit, fraction more. Wallow. 1, 2. Wallow. Wallow. No, more. Wallow. 1, 2. Wallow. That's it. That's the way it should be. Just out of interest, we'll just listen to it on our handheld. Obviously, I'm going to get feedback. Testing 1, 2. Testing 1, 2. Testing 1, 2. Testing 1, 2. What I'm trying to do is that transformer is still movable. Yeah, I mean there's a slight detectable hump. That's how they are. Right. Transmit power on the meter. Well, the meter sticks. You know, I'm not actually here to repair meters. These meters are troublesome. Out of interest, wonder what low power's doing, if it's got it. Yep, low power. See if it's adjustable. Switch to... No, it's fixed. It just goes through a ballast resistor. So that's or a dropper resistor, depending how old-fashioned you are. Yeah, so that's fixed. So on low power, it's doing 0.2 of a watt. Well, you know, it's supposed to be 0.4, but that's fixed. That's fine. Right. I think we'll leave it there because I've got to go on a mission this morning and do Mrs. Stingy's shopping. But at least we've got the power supply sorted and we've got the thing transmitting as it should do. So I will be putting the spectrum analyzer on it later. Right, so we're back on with this, and I've put another screw in the transformer because I ordered the wrong ones for something else. So I'll finally be able to sell a screw and get 6p back or whatever they were. So that's now screwed down properly. We will check earth continuity, etc. in a bit. So switch this back on and we'll go through the receiver. I said to the customer, I sent him an email, I said, do you know anything about this transformer being mounted on stilts? And he says, no, I bought it off eBay, and he's shown me a link to it. And I think the thing is, I mean, I was what age when I was born in 62, so in 81 I was 19 when CB happened, and as you all know, I was a licensed amateur since 79. The CB came a couple of years after that, and we had a television and audio shop in Yorkshire, and people started coming in with CB radio. And I've probably said to you before, the first one I did was an illegal AM FCC one because I didn't know what was what until I found out about it, and that was for a lady whose username was Luscious Lips. Anyway, I remember my late mother being in the shop and she brought this CB radio in, she said. I mean, I was out doing my organ building apprenticeship and I employed people. But my mother was in the shop and this young lady came in and she says, get him to look at this CB radio. Someone says, oh yeah, I'm sure, yeah. She says, what name shall I put on the job card? So she says, tell him it's Luscious Lips. So that's what went on the job card, Luscious Lips. Right, so 27791125 on the signal generator. First thing we'll do is look for the detector. So I know I've done these before, but the detector looks like it's the one down there. Right, we want 100 microvolts on the signal generator. About time that volume control got some service on in it too. Oh, now of course I've got this problem that I've got to hold things onto the speaker, haven't I? Because there's no extension speaker socket on these. I think Mr. Chippy's hidden all his crocodile clip leads from me. Mind you, it's his service hole I'm using, and it's his micrometer I got out. I need to order a cable gland for this, so it's not this set won't be able to go back today, but we'll be able to finish it off. We'll even be able to do an on-the-air test, but this isn't acceptable. Right. So we'll put the camera on that. And turn the bench light off. I'll turn the volume down a little bit rather than just the oscilloscope. And then we want maximum recovered audio. I'm going to have to use the other hand to hold that on. It would be the other way on, wouldn't it? Actually was spot on. Right, we'll now go down for much lower signal. I'm going to have to get a crocodile clip lead from somewhere. Right, let's borrow the crocodile clip lead off Mr. Chippy's bench while he's not looking. Get the sine meter to about 4 dB. So we're not saturating it. I'm not sure what that one is. I could look at the circuit. See if that's in transmit. We'll find out from the circuit what that is. Well, that doesn't seem to have made any difference at all. So let's look at these IF ones. Put the biggest signal on for that. That's frequency, so that's an unknown. We'll play with that one. Can't see any difference there, so that's another thing we'll look at to what it does. So far I can't see any difference at all. I wonder if we can see what these transformer numbers are. So the first one is transformer 1. So let's look at the circuit diagram. So transformer 1 is the first in the front end. Transformer 2 and 3. 2 and 3. Transformer can't actually read the writing, but it's I can't see that. So that's 5. So 1, 2, 3. One would presume that one to be 4. This wiring is very neatly around there. So I'll just very neatly pop it away from there for now to see whether we can see any numbering. It's T12. T12. So that's there. It's an early stage of the transmitter. So I'm glad I rechecked that. So the other one, which was a bit of an unknown, it's T14. Oh no, that's the crystal trimmer. That's the detector, and T6 is my next query. Well, that should make some difference. So we'll just recheck that. Right, well, that's vastly better with the core at the bottom. So I don't know why that is, but it is. So I'll just look once again, see if there's anything else we can get out of it. We'll see what we can get now for a cyanide reading. 1. I'll just untune that other one. Okay, so the best I can get is 0.75 microvolts, so it was 0.83, so we have an improvement. And let's just show you, we've got 12. Probably even drop it a bit less for 12. And if we look at the attenuator, 1 and 7, between 7 and 8, it's actually, if I look very closely, it's 0.73. Now it's got a delta tune control, so let's just fiddle with that and see how that affects the synad from the fact we're spot on frequency with the signal generator. That's positive. In fact, if we go negative, we can do 0.58 microvolts. Now, does that mean it needs aligning? Let's look at T13. I don't think T13 is variable. Anyway, it's better than it was. His transmitter's transmitting, and he's everything else is spot on. It's nice when they're a bit more sensitive than this, but this isn't the bee's knees of radios, is it? I'm sorry to say. Have any of you have seen the Comtel one? That was the repackaged Cobra. What was it? 60 something UK emergency kit. So the Comtel base was a walkie-talkie in a big box. This is a walkie-talkie in a big box. You know, so there's been some not so fantastic base stations. And that dreadful President KP77, which was a fully legal conversion done at factory level. Oh dear. Trying to get the VCO to lock on all 40 channels. So what have we got to do? We need to find the S meter, we need to find the squelch. Well, VR2 is going to be the squelch. Probably. Yeah. VR2 is going to be the squelch, if we can find that. VR2 is there. So that's something verified. So we'll get the squelch on to full on the radio. We'll now turn the signal generator to 100 microvolts. And hopefully it will open up. It does. It's absolutely spot on. So without adjustment, well, that is a turn up for the books. And say it's VR2's down there. So now we'll do the opposite. We'll turn the squelch, turn the signal generator to standby, turn the squelch down, set threshold, switch the signal generator back on. It's coming at 0.3 of a microvolt. And it goes all the way down to 0.2. If we, I mean, this radio here down to 0.2, it's just that the synod reading's not good. It's just a bit noisy with it. So, no, it's not insensitive. So that's set spot on. So we're going to have S meter to fiddle with. So let's see if I can find on the circuit. Just make a note of this on here, because I'm going to run out of memory in my brain. Squelch is VR2. I wouldn't be surprised if VR1 isn't S meter. Do you have to switch it on? So we've got full signal going in. Well, does the SWR meter work? Now, I'd set the RF meter, but we hadn't set the... We're not getting anything on the meter now. I'm going to take this apart. This isn't part of what we charge for. We don't do things like this. You know, it's like taking your car to the garage and say, actually, I'm going to take your alternator apart and see if I can mend it and save you buying another one. So I'll just see if I can do that. Right, so try not to fix it worse. So what's causing it to stick? Well, it could just be the bearings. So I really need a really tiny precision screwdriver. Quite here. So I'll just go and raid Mr. Chippy's bench. So the conclusion I've come to here is that the little inlay card has come unglued. So we'll use our Bostik adhesive and put a dab on there. I'm usually quite careful with the amount of glue we put on these type of things, but in this case it needed more. Just blowing on them, they both look like they're moving freely. So we'll come back to this in about an hour, I think. I'll leave it exactly like this. Right, I've been busy with doing the front panel. So, let's see. If we plug the mic back in, haven't quite got the meter back right, there we go. Are we on low power? You know what, it's actually saying 4 watts and it really is. Anyway, we'll come to that, and then the S meter is now working. Whether or not the SWR meter is another kettle of fish. So what do we have to do here? Press calibrate. Oh yeah. And the SWR meter works as well. Right, so we'll calibrate some of that. So the transmit is actually spot on, but it's variable resistor 4 at the back there, because I've been looking at the squirky diagram. So I'll just try and rear this up enough to show you, and as you can see we can alter that. So I'll put it exactly on the 4 because that's exactly what it's doing. Right, S meter. So 100 microvolts on the signal generator. I've cleaned that as best I can, but trying to get something in there, it's a sealed type. S9 should be there. Well, it's being a bit generous, isn't it? So So it's VR1, which is down there. That was squelch. If I said that correctly, I can't remember. Squelch. That needs to... I reckon that's there. Right. Well, I'm glad that's back working. He did say there's only 1 meter bulb working, but there is only 1 meter bulb, and it was dimmer than it should have been because of the power supply not being right. That's the brightness it should be. It's not a headlight. I know I've seen them lighting up like a headlight. So I've been doing my coloured things. So we've got we start with transformer 12 for a transmit, 11, 10, 9, L8, L1. We've just said RF meter is our VR4. Deviation was there, I didn't put the number. And on receive, transformer 1, 2, 3, 4, 5, 6, 7, detectors 8. Frequency adjust is that one, and variable resistor 2 is squelch, which is there, and S meter is there. So that leaves us with that one. We don't know what that does yet. I wonder what that does. And it also leaves us with that one, probably to do with the SWR meter. That intrigues me though, because it hasn't got a low power one. And theoretically that's in part of the receive. Now that's interesting, they've put the polarity protection diode in, yet it's a base station, which just shows how it starts like these have started life as a transportable. You just wouldn't put a protection diode in a base station. Well, I wouldn't anyway. So if we can see where there's some more presets. So we've got the SWR meter. That presets the RF meter. So that one is near I can't even see what it is near. It looks like, I mean, it's in like the power supply arrangement. Alright, the next thing we're going to do, I'm going to be having to change the plug on this, so we're going to open this up at this point, but it's going to have to be done again because I'm going to have to change the plug. They need to have shrouded pins these days, so they're not, what are they, 189? It's not going to kill the customer. I'm not going to charge him anything for doing it either, because I just want it doing for safety's sake, you know. So, just for now, just so we can get a pat test out, I'll just make sure they are tight. And it's actually got the right fuse in it. Amp, which is correct. Good. So all I need to do, and I've had to order it, is to put a cable grommet in there. there's two ways to, there's three ways to secure it. We could have used a cable grommet which clamps it. We can use a P-clip and an ordinary grommet. We'll do something like that, I think. P-clip and an ordinary grommet. But that bit of insulating tape round and no grommet is far from ideal. That's 3 sets now waiting for parts. There's an Amstrad 901 which I haven't published a video on because it's waiting for parts. There's the Audio Line 341 which is just waiting for a scratchy corner test, and now there's going to be this waiting for parts. Now where have I put the big crocodile clip for this? Goodness knows. It's going to be hold it on time. Right. See what we can find out. Excellent. So I don't know whether the angle's right, but everything's passed on a 500 volt test. Good. And sometimes when you open something up and the transformer's dangling like that was, I think to myself, I really need to just check that. Somebody's talking through our 77 repeater. You can just hear it over the background music system. I have a scanner connected to our tannoy system, and various frequencies are in that scanner, including GB3GR, the local repeater. And 77s and 2 metre calling channel and 6 metre calling channel, and it's only on a bit of a loft aerial, so to be honest, if anybody's more than about 4 miles away, it's not going to pick them up anyway, but it's just some activity while you're working. Right, so there's no point putting the lid on this, although I could put the lid on this just for the completeness. Looks like somebody's bubble wrap has affected the paint on this. Anyway, I'm sure he can, if he wants to do a better job of the paint, I'm sure he can sort that out if he so wishes. At the end of the day, it's 40 years old, isn't it? As you know, I've said enough times I don't do mobile phones, but it sometimes worries me about new models coming out all the time. Well, what was wrong with the previous model, you know? That's my take on it. Because CBs haven't got any better, have they? You know, apart from the fact that there were rule changes and that, and we've gone from the 2781 sets like this to, then we had the PR27GB, so you got the 40 CPT channels then on a separate set, and then it was combined in 97, and then the C multi-norms came out, and then post 2014 you've got the ability to use AM on CPT and SSB2, but the sets haven't got better. All this technology's moved on, they've not got better. So Now, don't get me wrong, there's some dire sets in 1981 as well. So we'll be setting up that bench 4A for selectivity tests very, very shortly. I'm clearing it down, just doing the accounts, and we'll get that on with it. And that's going to be interesting because we now rubbish the Fidelity 1000 is for that. So I put this in such an angle that, you know what, I better put one screw in this lid, because it's going to go all over the place. Now, one of the things was he was concerned about it changing performance when it got hot. So I'm going to leave this on overnight, but I think that would be power supply related. So if I didn't say so before, and by the way, we're on to the next day now. I got an emergency call out, so I had to go to 205 miles and sort something out. So this has moved on to the next day. I don't know whether I said so earlier, but this is the right bulb, and it works, and it's the right brightness. So I know you see some of these looking like a headlight, but that is correct, and it's just stuck there between the meters on a little clip. I suppose the meter's slightly discoloured because of age, but it's, as you saw when we did the front of the meter, it's not see-through, so it's just floodlit. Oh, he's talking a bit. I've got it on the aerial now for the final test. So I'm not going to change the bulb because it doesn't want to be different to what it is. What I'm going to do is I've had this on overnight because there were some concerns about it overheating and malfunctioning, but that was probably down to the power supply, which I've sorted out anyway. So it's certainly working all right. We'll just put one screw in for now because I need to do that cable grommet in a couple of days' time when that actually arrives. But just so we can get this video uploaded, we'll do the usual on the aerial thing. 19 Roger. Nineteen Roger. Well, that's nothing different, is it? Here we sometimes get somebody on, sometimes you get the odd farmer sat there on Channel 9. So there we are, that's the Murphy CBH1500. So you saw what happened to that. So yeah, I mean, it was kind of working, wasn't it, when he got it? But I mean, fancy perching the transformer on half a rig mount, you know. I just find that bizarre. That's why we've gone to the trouble of pat testing it. So just that cable grommet to do, change the mains plug, and it can go back to the customer. So thanks for watching the Murphy CBH. Oh, it nearly spoke. CBH 1500. What we've got